So if I do this video right, it should take me 2 minutes to cover the basics, and then there will be a bonus, I don't know, 5 or so minutes at the end of the thing if you want to see where the stuff comes from. But all that's really necessary is the first 2 minutes or so of this video. And what I really need to do is I just need to tell you that there are 4 new trig integrals to be memorized. So I hope you have everything else before that memorized. If not, seriously, get on that like a month ago. So the 2 that we already know. Everybody should already know that the integral of sine x dx is negative cosine x plus c. And we should all already know that the integral of cosine x dx is sine x plus c. Those are the 2 that we should already know. The new stuff is this: the integral of tangent x dx. We have not done this one before. The integral of tangent x is, and there are actually 2 different options. You can either use the natural log of the absolute value of secant x plus c, or you can use the negative natural log of cosine x plus c. I don't want to spend a lot of time on this, but I will mention why are there 2 different answers? It's because they're the same thing. Imagine if you took this negative power and brought it up here. Wouldn't you have cosine x to the negative 1? And that would mean 1 over cosine x, which is secant x. So those are the same thing, right? So there's that. The next one you need to memorize, that's the first one, is the antiderivative of cotangent x dx. There are, again, 2 options for this one. It's either the natural log of sine x plus c, or you can say that it's the negative natural log of cosecant x plus c. And again, that's for the same reason. If you take this negative thing, put it up here as a power, cosecant is already 1 over sine, so if you do the reciprocal of that, you'll get back to it being sine. So those are the first 2, the integral of tangent and the integral of cotangent. Now we get the crazy ones. The next one is the integral of secant x dx, which is the natural log of the absolute value of secant x plus tangent x plus c. And the last one is the antiderivative of cosecant x dx, which is the negative natural log of cosecant x plus cotangent x plus c. So those are the 4 new trig integrals that you need to memorize. Yay! And at this point, you can almost stop the video. Everything we know about integrals still applies to these. U substitution still applies. Having to simplify things before you take integrals still applies. Everything we know about integrals still applies. I'm just adding these 4 new integrals to your repertoire of integrals that you can do. Some of you may be interested in where these come from. To be honest, this one I think I already showed. I think we actually did that in one of the videos already, where we did a U substitution and then that was the answer. The ones that are sort of more interesting are these ones down here. So I'm going to cover the where that comes from. If you want to stick around for a few minutes and see that, you can. It's really not necessary. This is really just for those of you that kind of like to see magic. So I mean, this is adventure time through integrals. So come on, grab your friends. We'll go to very distant lands. So I'm going to try and do this one here. I'm going to try and do the integral of secant x. So let's say we want to do the integral of secant x dx. And really the method I'm going to use here is just the method of dark magic. It's where you say, I have an idea. I'm going to multiply this problem by secant x plus tangent x over secant x plus tangent x, right? I'm allowed to do that. That's basically multiplying by 1, right? Now you might be wondering, why would you ever multiply by secant x plus tangent x? you know, I don't know. It's hard to say. It's hard to say why anybody does anything. But you know, whatever. YOLO. I'm gonna do it. I'm gonna multiply by secant x plus tangent x. And now that I've done this crazy thing, I'm gonna do a u substitution. I'm gonna choose my u to be secant x plus tangent x. Ran out of space there, sorry. That means my du, I'm going to be running out of space even more here very shortly. The derivative of secant x is secant x tangent x. And the derivative of tangent x is secant squared x dx. Wow, that's really ugly, I'm sorry. So that means solving this out, I'm going to get du over secant x tangent x plus secant squared x. That's dx. So now, yay, I'm going to substitute this stuff back into the problem. I mean, I said this was going to be an adventure, so I think we're getting what we signed up for. I have the integral of secant x. And actually, I'm going to do something interesting here. I'm going to write this as secant x times secant x plus tangent x times, so basically what I did is I did this, and then at the end I have 1 over the secant x plus tangent x. So I'm going to do 1 over u. Now some of you may be wondering, why didn't I put u in for this? Part of it is because I see this right here. Right? My dx is du over secant x tangent x plus secant squared x. At this point, even those of you that were bold enough to go this far may have quit. If you haven't, good for you. Stick with it. Let's see what happens. And to be honest, if you stuck around this far, you can probably see it. This thing here could be factored, right? I mean, like, you could factor a secant x out of that. You'd be left with secant x times tangent x plus secant x. But wait a minute. Isn't that the stuff that I need to cancel with this stuff? And so really, all this stuff cancels out, and all that's left is the integral of 1 over u du. Like, talk about magic, right? This is the natural log of the absolute value of u plus c. And remember, the u that I chose a while ago was secant x plus tangent x. And so that shows us that this thing is indeed the integral of secant x. So as long as you can memorize that, you're fine. And if you have trouble remembering that, you know, I wrote it on the next page. The integral of secant x dx is the natural log of secant x plus tangent x plus c. So hope that makes sense. Hope that's clear to everybody. And that's really all I have to say for this. So yeah, good luck in the assignment.